Hey everybody, I'm Rob Solomon, Solutions Architect at CrowdStrike. Organizations of all types are migrating to the cloud. And even right from the outset, they're already planning their application modernization priorities so that they can get the full benefit of that migration. Containerization is a key app modernization pattern. But operating containers at scale can be very complex, and securing those environments entails some additional challenges. So today we're going to talk about the cloud and container threat landscape and some of those security challenges. We're going to talk about container best practices. We're going to step through that, and we're going to look at some GitOps architectures using CrowdStrike Falcon Cloud Security. And then we're going to step through Falcon Cloud Security to show you how we can help you secure your container environment. And we're going to sort of summarize the Falcon platform. Hopefully we'll have some time for Q&A. So just to level set, what is actually driving this migration in the first place? What are those benefits? Well, first and foremost, it's agility and speed, the ability to deploy infrastructure more quickly. Obviously, ordering bare metal servers to increase your capacity in a data center takes time. But with the cloud, you can deploy massive infrastructure in minutes or hours anywhere in the world. Cloud lets you scale. It lets you scale out, lets you scale in response to actual utilization. And it also drives cost optimization because you can key your actual consumption with customer utilization. So you can scale out as your service grows. You can scale out quickly in response to peak utilization and only spend money on that infrastructure during that time. And then as the utilization reduces, you can scale that down again. And all of this is possible because of the ability to automate that infrastructure in infrastructure as code. You can act in response to your code. You can act in response to events. You can automate that infrastructure to take action on your behalf. But when operating in the cloud, or really anywhere, well, the cloud in particular, security teams are dealing with a broad range of specific security challenges. The ability to deploy that infrastructure rapidly and granting that access to a wider range of people means that folks who may not have full stack experience in deploying secure workloads now have the power to deploy those workloads. It creates challenges for IT and security of visibility. How am I aware of all of the services that have been deployed? Did we set the right permissions to allow the right people to be able to do those things? And then making sure that those assets are actually secured. How do you drive that security standard across your entire multi-region organization and infrastructure? There's new levels of complexity. CJ Moses was talking about just the rate of deploying new services and features on AWS. And learning how to deploy those services in a secure way is not necessarily obvious, especially for people who are new to the cloud. So there's a lot of misconfiguration out there that makes it easier for adversaries to take advantage of those misconfigurations. The problem of runtime threats is always there. Whenever you have an actual workload running on an operating system with packages that have published vulnerabilities and ways to exploit those vulnerabilities, that's going to be a key area that needs to be secured so that runtime threats. And the adversaries are looking for opportunities to exfiltrate and monetize data or to disrupt operations. And there's a skills shortage, both in cloud operations, in security in general, and cloud security in particular. So bridging those gaps is another challenge. Even if you have the budget to hire those people, it can be hard to find them. So in our global threat report and our most recent cloud risk report, I wanted to pull out a few specific stats, just to kind of define the kinds of challenges that people have. So 84 minutes is the average time to break out. That's lateral movement. So once an attacker gets a foothold in the environment, on average, it takes about 84 minutes for them to do discovery, figure out what resources they have, maybe pull down some additional tools, and then attack laterally. And once they do that, once they attack laterally, it becomes a lot more difficult to contain that breach because adversaries are also covering their tracks as they go. And 84 minutes, by the way, is down about 10 minutes from last year, and that was down 10 minutes from the year before. So adversaries are getting faster and faster. These attacks happen quickly, and they plan ahead, and they are increasingly sophisticated. 71% of those attacks are malware-free. They're not launching malware first. They're actually doing hands-on-keyboard interactive attacks. They're able to adjust based upon what they find. So traditional signature-based antivirus or signature-based intrusion detection can be hard to do because these are zero-day attacks, and again, they're constantly iterating and innovating and coming up with something new. And I mentioned before that misconfiguration is a big problem. 60% of the containers that we see in our environments, and these are a wide range of customers. Some of them are customers who don't use CrowdStrike but have experienced an attack or a breach, and they contract with CrowdStrike to do incident response or forensic investigations. So of all of those environments that we observe, we see about 60% of the container environments have some serious security misconfigurations that can be used to accelerate an attack. So I was mentioning before, there's, if we look at the MITRE ATT&CK framework, there are a number of steps that adversaries take to get that foothold in the environment. And it starts with initial access. And the two main forms of initial access that we're seeing in cloud environments really boil down to stolen credentials, identity. I mean, these credentials are actually advertised on the dark web. So adversaries can just go in and buy sometimes admin privilege access to the company or industry that they're targeting. And the other way is just plain old-fashioned vulnerable web-facing applications, because patching is still a thing. Application packages, Tomcat, PHP, whatever, still has vulnerabilities that can be attacked and leveraged to perform remote command execution in command and control sessions. And again, once they get to that 84 minutes, not always 84 minutes, right? It could be shorter than that. That's when the attack really spreads out, becomes difficult to contain. So we say to stay ahead, you really need to detect what is happening in 1 minute. You need to understand what the attack is, what they're going for, what their techniques, tools, and practices are. And then you really need to respond in 60 minutes. And again, 84 is the average. We've seen it happen in as little as 17 minutes. So not that much time to respond. So one example of an attack that we observed, and this is in our cloud risk report that you can download from our website. That initial access was achieved through a vulnerable PHP application. Once they established themselves on that host, they were able to use built-in OS tools to get a sense for what their level of access was, what other tools might be in the system, and what resources, like credentials that could be pulled from a file, even hard-coded cloud credentials. Setting up that persistence, the ability to maintain that control across reboots. They set up a cron job to reinitiate the attack. And establishing that command and control session by pulling down additional tools using common open source tool, curl. This is not an uncommon pattern, and we see a lot of attacks that, again, fit these MITRE ATT&CK framework stages. So how do you secure against that? That's what we're going to talk more about in containerized environment. But just to take a step backward, what are containers? What is the challenge of containers? We're not going to go into a lot of depth about that, but just sort of visualizing what the challenge is. We had bare metal servers, and you manage one individual bare metal server that has one OS and running a single application. And we improved our utilization, our scale, by implementing virtual machines. So you can pack a number of virtual machines on bare metal. Each one of them is running its own full-scale OS. So what's different about containers is that the OS is virtualized, so you can squeeze in a lot more containers. It's not uncommon to see 100 containers running on a bare metal host. And in a large-scale environment, you could have hundreds or thousands of hosts all running numerous containers. So how do you stay on top of that? Well, there are these orchestration layers, right? AWS has Elastic Container Service, and obviously Kubernetes is a key tool to be able to orchestrate all of those containers at scale. So just quickly looking at this architecture, there's two pieces of the architecture. You have the control plane on the left and the data plane in the middle. The data plane is comprised of worker nodes, EC2 instances, or serverless Fargate, where the workloads themselves are running on that resource. The control plane, that's what's managed by EKS. And EKS provides a lot of security of that service. So there's a lot that using EKS, folks don't have to necessarily worry about, except to think about what is that control plane, right? All of the commands to configure the cluster are going through a single API server, so that there's always a clear, consistent picture of what's happening in the cluster. But it's through that API server that commands can be, configuration can be established, and then you have a controller that's always checking automatically behind the scenes to make sure that the actual state of the cluster resembles the configured state. So there are control loops that are always, checking the current state and making changes, terminating pods, creating other resources to make sure it's as you configured. That's the key part. You don't have to take action. The action that you take is the configuration initially. So if we think about Kubernetes security and what you need to account for, many of the things on this list are already familiar. So it's not a complete departure, but there are a few different things. So just sort of running through them. That image security piece. The container image itself, which is a packaging format for application code and includes all the libraries and files and things like that it needs to run. And that container image is an immutable package, or potentially, ideally, an immutable package that can be run in any containerized environment. Those container images include packages. They include libraries that themselves could be vulnerable. Runtime security, making sure that the workloads that are running in the container environment, on the pods, that there's no malicious activity. And will detect malicious activity and respond in real time. Pod security is a bit of a departure in container environment. So the pod itself is a structure that encapsulates one or more container images. but the pod itself can be configured to run in a privileged mode or with least privilege. Obviously, least privilege is going to prevent or slow down lateral movement in the event that container is compromised. But it can be hard to do. It's not easy. It's fairly complex. The tools to implement that container security are in flux. We had pod security policies. We still have OPA gatekeeper and other services, but they're not easy. It can be time consuming to learn how to do that and to properly configure each container image, each pod, each microservice with the right capabilities to prevent it from escaping into the host. If you allow a pod to run in privileged mode and it gets compromised, it can actually escape to the host and impact the host itself, other containers, and move laterally from there. So it's a very important area. Identity access control, like we're always talking about least privilege, and it can be inconvenient when you're developing new applications, but those unnecessary elevated privileges and policies are what adversaries are looking for, and that's what really helps them accelerate lateral movement in their attacks. The infrastructure itself, making sure that the hosts are patched, making sure that you're running a current version of EKS, of Kubernetes, edge network security, really every aspect of the cluster and where it's located in your infrastructure as a whole, making sure that that's all secure. Making sure that the data that you store on containers, making sure that the secrets that are being used by pods to authenticate to custom applications, all those things need to be encrypted to prevent it being compromised and used against you. Obviously, network security, at least privilege, network segmentation is really important. And Kubernetes and the Kubernetes ecosystem gives you a lot of tools to limit that network access so that one particular microservice can only access the other microservices or external services that it needs to. So it gives you the tools to provide that granular level of security. But it takes time to learn them and it takes time to implement them. Multi-tenancy. If you're running multiple applications, you have multiple teams running in the same Kubernetes cluster using structures like namespaces to maintain that separation between namespaces and least privilege roles so that you don't have, let's say, a developer, operations person, whatever, learning Kubernetes and making a unintended configuration change to the cluster that brings the whole thing down. So you're able to limit the scope of access. Detective controls, implementing that observability layer so you know what's happening inside the cluster. You know if you've been attacked is critical. And obviously the incident response and forensics. And one of the interesting things and challenging things about running a container cluster is that there is a wealth of logs that is associated with each pod. Pods are being deployed, they're being destroyed constantly. That's part of the normal life cycle of a cluster. But as soon as, if you're not forwarding those logs and storing them, you might lose that visibility as soon as the container goes away. And finally, regulatory compliance and making sure that the configuration of your cluster adheres to compliance frameworks and best practice standards. So these are really all the things that you need to keep in mind in order to secure your cluster. And if we boil it down, the key things that we're looking at that you really want to focus on is making sure that you have that layer of visibility in your cluster. Again, you've got so many pods spread across multiple hosts, and does the security team, are they aware of what is an approved new microservice? It's really a lot to manage. That resource churn, the fact that pods and other resources are constantly being created and destroyed. What's valid? What belongs there? Am I even aware of it? And that creates a dynamic area of impact, a dynamic attack surface. You bring up a pod, it's another IP address, it's another target, potentially, another potential area that an adversary can get a foothold. We talked about privilege escalation, elevation. You want to make sure that you use that least privilege so that you don't make it too easy for the attacker. And your operating model. So I've done a lot of trainings, hands-on trainings for people about containers, and when we do these hands-on trainings, we use the command line tool kubectl in order to take action on the cluster. And people ask sometimes, is this how I'm going to operate my cluster using kubectl? Well, not really. You don't want to be taking these manual actions. You want to try to automate as much as possible so you can have a consistent cluster environment. You learn how to configure your cluster. You learn, you render that configuration in code. You can use that over and over again to deploy a brand new cluster in another environment for redundancy, whatever. So learning to use those automation tools is critical to success. And of course, the skills gap. So it's not just cloud, it's not just security, but Kubernetes. This is a new thing, even for people who've been doing it for a while. They're still learning all the ins and outs, and Kubernetes is developed at a pretty rapid clip. But with the challenges, there are also opportunities. And those opportunities, again, really boil down to the ability to automate, to build event-driven rules that will take action on your behalf, and to render that infrastructure as code in things like CloudFormation or Terraform. And what we see in really mature Kubernetes shops, EKS shops, is teams who are using GitOps. So we've heard of DevSecOps shifting left. GitOps being operations using Git source control as a single source of truth. So in this particular diagram, we have our Git repo, which acts as a single source of truth. You have multiple people, multiple teams who are developing application code, developing the infrastructure, and they're able to check in their changes in that single shared source code repository. So we have our application code lifecycle and a separate infrastructure as code lifecycle. So imagine a situation where a team is building a new CloudFormation template, or they're modifying one. But before we get to that, code pipeline. So code pipeline is a managed service from AWS that allows you to build GitOps and CI/CD pipelines. So so for this example of building a new template, what code pipeline will do is it includes an agent that will detect changes. So when the team checks in new infrastructure as code changes into the repository, that will automatically trigger a build job. That build job being pre-configured by the team that manages the development pipeline. In this particular case, we have a code build job. Code build is part of the code pipeline suite of tools. And in this case, we have a code pipeline job that will take that CloudFormation template and build the AWS services that it refers to. So one of these services being Amazon EKS. Now, as soon as those services are deployed, assuming that you have already deployed cloud security posture management, there are different cloud security posture management tools. The Falcon Cloud Security, our tool, Falcon Cloud Security Posture Management, part of Falcon Cloud Security. The best practice is to deploy that as soon as a new account is created. So that's part of your landing zone. Deploy a new account. That account is automatically registered with the Falcon platform. And as soon as you deploy services, it just starts scanning in the background, and it's scanning for misconfigurations. And part of that registration is that we create an IAM role, and we create an EventBridge rule. What is EventBridge doing here? Well, CloudTrail is an AWS service that has a running stream of all the API activity. This is one of the benefits of cloud. It's all API driven. Everything that's happening to all the services, all the configuration, the changes, they're all happening as a series of API requests, and those are being captured by CloudTrail and streamed through EventBridge, where it is forwarded to our EventBridge in the Falcon platform in AWS. So this is a stream of telemetry that we're ingesting and analyzing. When you deploy a new cluster, EKS cluster and ECS cluster, at the time of the creation of the cluster, you can include in your infrastructure as code deploying the Falcon Kubernetes protection agent, which is specifically for the cluster as a whole. Looks for misconfigurations, and it discovers all of the resources, so you have that visibility. So in the background, it's listening to those API calls. Remember, I talked about the API server, that single location where all of the communication is coming through. So the Kubernetes protection agent uses that to discover every new resource that's being created. And at the same time, you also have the option of deploying runtime security. And in an EKS cluster, for example, we use the Kubernetes daemon set structure so that as your cluster scales, worker nodes, you deploy new EC2 instances with each new host, with each new worker node, the daemon set will deploy one pod, and that pod is the Falcon sensor that's built for containerized environments, and it will protect, it runs as a privileged container because it has control over the whole host and other containers. It can protect the entire host and everything running on it. It's also able to take action. If it detects malicious activity, it can stop that malicious activity automatically. So all these components can all be pre-deployed so that by the time you're creating services, launching resources inside of the cluster, they're all automatically being protected. You don't have to think about it after the fact. You're building in the security from the outset. Now, the Falcon Cloud Security Posture Management, two ways that can be used to improve your security posture. One way is to actually deploy your infrastructure as code, run it in a non-production environment, allow the CSPM to scan that infrastructure, and we provide actionable guidance of what is a best practice security configuration, what are the highest priority, highest severity misconfigurations that should be attended to as soon as possible. And we provide an opportunity to automatically apply that remediation, but we provide code samples that can be taken and fed back to the infrastructure as code development team, incorporated into the templates, and now all of the infrastructure that's being deployed subsequently from those templates benefits from that improved level of security. So you've got that process. Coming soon, end of this half, early next half, we're planning to deploy infrastructure as code scanning. So that will also be coming in the near future. So the infrastructure as code templates can be scanned before even deploying the infrastructure. Now, pivoting to the application code lifecycle, developers are building new application code for whatever features they want to build. And presuming the intent is to containerize that code to run in a containerized environment, checking in that code change, again, will trigger a code build job. And the code build job, the first thing it does is create a container image. So rolling out of the creation of the container image, you can build in Falcon image scanning to scan inside of the container. It looks for vulnerable packages. It's looking for misconfigurations like hard-coded secrets, not using pod security, applying too many pod capabilities, Linux capabilities that would allow it to do things you don't want it to, like escaping into the host. So the image scanning, when it completes, will provide ample reporting to show you what the actual vulnerabilities are. And if it exceeds a certain threshold, it will fail the build job. And if it succeeds, it will move on to the next phase, which is pushing the image to ECR and potentially deploying it into a non-production or production environment. So looking at it as a whole, looking at the different Falcon Cloud Security components, these are all part of an integrated platform. All of the data from all of these components is all ingested and correlated together so that an awareness of particular cloud misconfigurations will provide insight into the severity of certain vulnerabilities that might be discovered through CWP. And all that together points to where you need to focus first, where you need to pay attention, improve your security, because those are the areas that are going to have the biggest impact in the near future. So sort of digging into or reviewing the component parts, looking at image scanning. So here is just sort of focusing in on your pipeline, where you have a developer developing code, checks it into the Git repository, that triggers a job, that creates the container, does the scanning. If it fails, the build fails. If it succeeds, that triggers the next part of the process. So that's that part. Looking at the next part, we can also do code scanning on a registry level. Because sometimes you create a container image and it has packages, and those packages might be the latest versions, but in another week, in another month, it might be that those packages, someone discovers vulnerabilities. So you can also register up to 16 different OCI compliant registries and configure it for background scanning. And our Falcon platform provides insight into the kinds of vulnerabilities that you're seeing, which images have them, what the severity is, to allow you to plan your response. Falcon Cloud Security and Amazon EKS, the runtime sensor-based component I mentioned before, you can deploy as a daemon set on an EC2 host. You only have to do that deployment once. It's the benefit of a daemon set. We didn't invent it. That's a Kubernetes structure. So we're using the Kubernetes native tooling to make it easy to cover all of those containers. So we're not baking the sensor into a container image. We're protecting the host itself and protecting all of the containers in that host. So it understands the containerized environment. Now, you might be running your container environments in Fargate. Can't run daemon sets on Fargate. You can't interact with the host in that way. So we have an injector that will inject a sidecar at the time that the pod is deployed into Fargate. And that sidecar only has access to look at that one particular Fargate pod. And finally, the cloud security posture management piece. So one thing I neglected to say before when I talked about the EventBridge rules, there's the outside-in scanning of the API layer to look at all of your configuration to make sure you're following best practices. The EventBridge piece that is sending information from CloudTrail through EventBridge into our environment is looking for behavioral indicators of attack, anomalous behavior that could indicate an attack in progress. So this is really how our platform works. It's looking for those little clues, those little breadcrumbs, to see if you put them together, does it add up to an attack sequence, a known or not previously seen attack sequence. And that's how we determine whether there is an attack in progress so that we can take action. Now this piece of it, the cloud security posture management, this can all be automated. This is not something that you have to manually address. So you can create your control tower multi-account landing zone and configure it so that with a CloudFormation template, we have just released as part of the built-in competency that you deploy that template, and every new account that you provision through Control Tower will automatically get registered with the Falcon platform. So that all happens in the background. Again, you do it once, you don't have to think about it. It's protecting you in the background. So now we're going to walk through what it actually looks like and how you would use it in a real-life scenario. So kind of stepping through these different components, the container image vulnerabilities. I think it's maybe, oh, that's not too bad. The thing I want to point out is that we incorporate vulnerability management as part of our sensor. And we use that same platform that we call Spotlight to understand the vulnerabilities inside of the container. We're scanning those packages. So here you see there's a CVE ID, the common vulnerabilities and exposures, the way that we can all talk about known vulnerabilities. And they each have a published severity. And you can see that in the second column. Now in the first column, there's something called the expert rating, expert AI, which is something that we have developed that takes into consideration not just the CVE security, but the overall context. How likely is this vulnerability to be exploited in the real world? Are there published exploits that will enable you to handle it? Are the adversaries actually using this exploit? And given the rest of your environment, given the context, given your misconfigurations and other vulnerabilities, is this likely to be exploited? So we have a separate prioritization. Sometimes it aligns, doesn't always align, but it lets you focus on what's the most important to secure your environment. In the Kubernetes Kubernetes protection agent, we're scanning the cluster as a whole for misconfigurations. Now here's some examples of misconfigurations that we see. Again, the privilege escalation component, the pod security component, is really where we see a large amount. Just north of about a quarter of all the containers that we see have containers running in a privileged mode. So here the detections that we're finding are largely about having too many Linux capabilities that the application that's running inside of it doesn't actually need. Network capabilities to establish sockets, maybe for running network tools, may or may not need it. Or running as root. So we provide all of that visibility, and you can decide whether you actually need it for running your application. And then the overall cloud security posture management piece, we're scanning all of the AWS services. I'm filtering here, just looking at EKS and IAM, which of course IAM is going to be a key service no matter what you're using. Cuts across all of the AWS services. So here we see that same severity rating, and we're comparing your configuration based upon regulatory compliance best practices. Here we see like the first one, EKS cluster VPC endpoint access is publicly enabled. That's the default. And just because it's publicly enabled doesn't mean that you're going to be able to exploit it, but with all of the published credentials out there, if your credentials get stolen, then someone's going to be able to just walk right in the front door. So these are things that you might think about to protect. Now this is, the next couple of slides are focusing in on runtime protection. So the that sensor that's running, as Damon said, or as a sidecar, is looking at all of the process activity, all the runtime activity that's happening inside of the pod itself. And if it sees something amiss that is an indicator of attack, it can take action. And we represent that as a process tree. We provide that visualization so you can see which process spawned the malicious process. Now, when we make a positive determination, again, on a automated, on the automated level, the sensor can take independent action without any human intervention. When it makes a positive determination that the activity that's happening is malicious, it can take action right then and there. So we see this wget process. We'll just kind of step through the information here. So we also really focus on providing information and the ability to have the visibility to do forensic analysis or for you to do your own incident response. See, we provide here information about what the host name is, the EC2 host. You can pivot from there and see what region it's located, again, so you don't have to do a lot of hunting for that information. Container ID is populated. That indicates that this is a container and not just a EC2 host. And colored in red and with this icon, we can see that this wget process was identified positively as malicious, and it was terminated right then and there. So the sensor running in privilege mode is able to take that action on the worker node itself. And you can pivot from there and look at the event timeline, so you can figure out how this started. How did they get in the first place? What was vulnerable? What was the security gap? So here we see that the initial access was achieved by exploiting a public-facing application. And you can see the tab below, dash, that's enabled, that's associated with that phase. And that dash is simply a lightweight Debian shell. So in and of itself, not malicious. So the policy behind the sensor in this particular scenario is running with the default policies. Default policies, sort of a trade-off between the most secure and just observing. So dash, not necessarily malicious, but dash spawned this wget process that you see right there. That's the one that was automatically killed, and you can see right here that it's not running. But right from here, right from the event timeline, you are able to kill that dash process, because if you're running the investigation, you look at that, you're like, oh, this really doesn't belong here, and you can make that determination and you can just terminate the process. And we have that capability as part of the sensor. We call it real-time response that enables you to send ad hoc commands to a compromised host. For incident response, you can collect data for forensics, and you can even network contain that host while you conduct your investigation. So just to review, the components of Falcon Cloud Security, focusing on the cloud-native protection, shifting left, being able to build protection into CI/CD workflows. You can create automated remediation workflows. You can build your own API integrations. We expose the threat graph and many components of the application, and more and more of that is coming in the near future. Stay tuned. The agentless security that operates on the API level that we're able to take advantage of through those IAM rules. One component that I didn't mention was the cloud infrastructure entitlement management. Your identity security is critical. CIEM will show you if you are using roles with permissive policies that may not be required, and we'll give you that insight and provide guidance to moving toward a more least privilege environment. And finally, the runtime protection. Our runtime protection is essentially the same sensor that we use for workstation, servers, multi-cloud, multi-OS, same sensor. We derive a rich telemetry stream And I want to make a comment at this point because sometimes people wonder, hey, these containers are ephemeral. Why do we have to worry about them being attacked? Well, you can see these attacks happen very quickly. A vulnerable application can be exploited on a container as well as on bare metal or VM. But the other thing is that each one of these containers, each one of these environments, you're not only protecting it, but you have a sensor in your environment that's collecting more telemetry and giving you insight and visibility into your environment. Because the way that the Falcon platform works is by taking all this data together, as we'll see in a minute, and deriving insights. So the more data that you can ingest, that improves your security. You're getting from more data points and data sources. And we ingest over 1 trillion events per day. We're tracking 200 plus adversaries. Why is that important? By understanding the adversaries, we know what industry they're going after. We know what their goals are. We know what their tactics and tools are. So we're able to identify them and anticipate their next move. So we ingest all this data into our cloud at scale. We're able to scale out our analytics. We're able to scale out our ML models that are always being trained on new data. And we take that data, and part of processing it is constructing a threat graph that shows all of the connections, the relationships between different attack phases. Our asset graph shows connections between different infrastructure resources to help you do the investigation and see what might have been impacted if you are actually compromised. And the intel graph showing the adversaries, their behaviors, and the connections and the tools and tactics that they're using. So we take this data and we've built our platform on top of it. That single data source, we focus on quality data, and our managed, our service layer, our security researchers, our threat intelligence researchers, our threat hunters are using all of that data to find the next threats, to look at those new patterns. So the automated machine learning and analytics is sort of feeding anomalies for investigation. And the teams will look at it, they'll investigate, they'll say, oh, this is a new zero-day attack. Build that into the platform, and then all customers using the platform are now protected against it. And all of the different products that we provide different level of functionality, but using that same essential data source. So if you're interested, you'd like to move forward, I think you saw in your seats there, there's a flyer for the CrowdStrike Cloud Security Risk Review. We'll deploy Falcon Cloud Security in your environment and give you a report on your cloud security posture, any existing runtime threats. Very often when we come to a new customer and we deploy our sensor, across the environment, we see that an adversary has made themselves comfortable for months or years. The sensor will often just clean that up, but you can do that and get a $1,000 AWS credit. You can download our Cloud Risk Report. I didn't put this here, but our Global Threat Report, also available online. And we also publish integrations with CrowdStrike and AWS, other clouds, and those are all open source, so you can take a look at those as well. Thank you very much. Please complete your session survey. If anybody has any questions, please stand up, say the question, I will repeat it.